Welcome back to the Deep Dive. This is the place where we take those dense stacks of documentation, technical papers, and blueprints, and we pull out the core knowledge you need. The goal is to get you well-informed and, well, massively more productive, fast.
And our mission today is all about that productivity multiplier. We're really moving beyond the early days of AI, where prompting felt a bit like a dark art.
Right.
We're diving into a concept that, honestly, developers and analysts are calling the single biggest accelerator we've seen since LLMs first came on the scene.
And that is Claude skills. This is the leap, really, from just chatting with a generalist AI assistant to configuring a specialized, super reliable, and reusable agent that can run these complex workflows with, like, zero guesswork. So if you've been struggling with inconsistency or that weird context drift, or just the headache of explaining the same thing to the AI over and over again, this deep dive is absolutely for you.
Our main source material for this is a really powerful technical breakdown. It's titled Claude Skills Explained: 4 Skills to 10x Your Coding Workflow. And what's great about it is that it doesn't just show you how to use a feature, it gives you the whole ontology, really, for turning this generalized intelligence into predictable, repeatable, and most importantly, scalable machine expertise.
Okay, let's unpack that. Our mission for this deep dive is to understand this transformation from top to bottom. We're going to start with the foundational why. The 3 core benefits that really make creating skills a must-do for any professional workflow.
And then we're going under the hood. We're going to look at the technical architecture, how the agent virtual machine works, and the really critical difference between a skill, which is its internal logic, and a tool, which is an external action.
And finally, we're going to spend a good chunk of time on 4 specific, really high-impact skills. These are things that codify senior-level knowledge. We'll be focusing on a pretty complex example, securely integrating a financial platform and even automating the whole process of a senior-level code review.
This whole shift, it really represents the maturation of how we use AI. Think of it like moving from a general-purpose screwdriver to a custom-built automated factory machine.
That's a great analogy.
Claude skills are those factory automation tools. They fundamentally tackle the 2 biggest challenges that plagued the earlier LLMs, that inconsistency in the output and the context drift we mentioned. When you codify your process into a skill, you eliminate that reliance on temporary conversational memory. You transform the AI from a creative assistant into a reliable, standardized, and truly specialized member of your team.
That sets the stage perfectly. So for the person listening who's already stretched thin, maybe they're juggling a business, a coding project, or just trying to pull knowledge together from all over the place, why take that extra step to build a skill? What's the immediate, tangible payoff?
Well, the payoff is immediate. It translates directly into recovered time and, maybe more importantly, guaranteed quality. The 3 core benefits, they address the most persistent frustrations of those earlier prompting methods. The first, and I'd argue it's the most crucial for maintaining professional standards, is that skills ensure consistency for specific and repeatable tasks.
Consistency. So that means eliminating all that variation. Right.
Yeah.
But I thought LLMs were, inherently probabilistic. How does a skill force a deterministic or at least a highly predictable outcome?
It works by capturing the entire necessary process. The methodology, the configuration, all the constraints. And it bakes all of that into a reusable blueprint.
Okay.
Let's go back to that design example from the source material. Creating a nice front end.
Right.
In the old world, your first try would need this massive prompt defining every single detail. You'd have to say, use React, use Tailwind CSS version 3, the primary button teller has to be hex code, #4CAF50, make sure all components pass WCA accessibility standards. Use the interfont stack.
Yes. Wow, that's maybe 100 words of just meticulous instruction just to define the word nice.
Exactly. And even with all that detail, if you started a new conversation tomorrow and just said, make another nice front end, the AI might drift just a little.
How so?
It might swap out your chosen component library for one that's similar, or maybe it fails to stick strictly to those accessibility standards you laid out. The result is subtle, but it's costly rework.
And that rework is exactly where all your productivity gains just evaporate.
Precisely. The skill eliminates that drift entirely.
Right.
Once you capture that original perfect front-end spec, and I mean including the specific hex codes, the entire typographic hierarchy, the choice of component framework, all the accessibility rules, you save all of that configuration inside the skill.
So the skill itself becomes this persistent, high-fidelity memory of the process.
That's a perfect way to put it.
So now, instead of typing out 100 words of config, I just type 2 words, front-end design. The skill triggers, and it enforces all those rules for me automatically.
That is the power of repeatability. The skill is essentially telling the AI, do not guess. Follow this exact standard operating procedure for design. This standardization, it just dramatically reduces what you could call methodological hallucination and ensures you get predictable, high-quality output for these routine actions. And that frees you up to focus on the truly new, complex parts of your project.
That focus on quality control and standardization is huge. Okay, let's pivot to the second major benefit. This one has to do with the AI's working memory. I know context management was a total nightmare in the early days.
It was, and that brings us to context saving. This is all about optimizing the AI's, let's call it cognitive load, for efficiency and relevance. Before skills, we had to rely on what the source material called Claude rules, or just static system prompts.
Ugh, those giant blocks of text, sometimes hundreds of tokens long, that you'd have to stick at the start of every single session. The AI's personality and constraint file.
They served a purpose, but they were deeply, deeply inefficient. So if you were a developer using Claude, your prompt might have rules for debugging Python, rules for writing documentation, rules for handling certain file types, and rules for security compliance. All of that had to be passed to the agent in every single turn of the conversation.
Even if I was just asking for a witty suggestion for a commit message, all the Python debugging rules were still taking up space in the context window.
Absolutely. They were just occupying that valuable context space, which is the AI's limited working memory. And the more irrelevant data that eats up that space, the less room the AI has to actually process the task at hand.
Which means responses get slower, and the AI starts to forget details from earlier in the conversation much sooner.
Yes, it increases both cost and latency. The skill advantage just flips this model on its head. It goes from being static and mandatory to dynamic and optimized.
How does it do that?
Well, Claude automatically performs a relevance check. It reads your current request. Let's say you upload a PDF and ask for a summary. The agent scans its equipped skills, and it only activates the one that actually matches the task. In this case, maybe the PDF handler skill.
So all the other skills, the front-end design skill, the Excel sheet skill, they just stay dormant. They don't get loaded.
Exactly. They stay on the shelf. It's intelligent resource management. It's like having a library of specialized reference books, and the AI only pulls the relevant book off the shelf when it's needed, leaving all the others untouched.
This optimization must save a significant amount of context space. And I imagine it improves response efficiency too.
Dramatically. And it ensures that the AI's full processing power is focused on the current task, which gives you more accurate and focused results. It's a massive kind of hidden cost saver and speed boost.
Okay, so that's efficiency and consistency covered. The third reason you mentioned hints at a bigger organizational win. It moves us beyond just individual output.
That's right. The third benefit is the ease of sharing and standardization. If the first two benefits are really focused on the individual user's experience, this one is all about organizational scalability. We can really think of Claude skills as standardized operating procedures, or SOPs, that are executable by the AI, not just readable by humans.
That's a powerful distinction. An SOP is usually a document that people should follow. A skill is a protocol the AI must follow.
Exactly. And the crucial part here is portability. Skills can be easily exported as a simple zip file. So imagine you work in a regulated industry, and you've perfected a methodology for summarizing a legal contract, highlighting specific clauses, checking for liability markers, formatting the output in a very strict way. You codify all of that into a legal summary skill.
And instead of training 50 new hires on that complex process or emailing them a document they might misinterpret, I just share the zip file.
Exactly. They install the skill, and their Claude agent immediately performs the task the exact same way as your senior legal analyst does. It's instant enforced standardization across the entire organization. You've essentially transferred institutional expertise in a single file.
And the source material mentioned something about subagents here. How do they fit in?
Right, that's key for complex projects. You might deploy a main agent, but you could also have several specialized subagents, like a documentation agent, a testing agent, a database schema agent.
So each subagent has a different role, maybe a different primary system prompt.
But, and this is the critical part, all of these subagents can share the same foundational set of Claude skills. So if you have a data privacy skill that enforces GDPR compliance, every single agent working on the project, it doesn't matter if it's writing code or documentation, it will adhere to that exact same privacy standard.
That is the ultimate defense against process drift. But this does raise a practical challenge, and I think this is important for our listeners who are managing complex systems. What about maintenance? If this skill is the single source of truth, who maintains it when, say, the underlying security requirements or an external API changes? Does this create a version control headache?
That's a fantastic point, and it moves us from creation to governance. Now, while Claude doesn't inherently manage, say, Git version for the skills themselves, the power is in the fact that the skill is centralized. You are only updating one skill.md file and maybe one set of Python scripts.
Instead of chasing down 50 different employees to update their personal system prompts or local documents.
Exactly. The skill becomes the single source of truth for the methodology. If the Stripe API changes, you update the Stripe integration skill just once, and instantly, every agent and sub-agent using it is compliant. It simplifies maintenance dramatically. It turns a distributed problem into a centralized one.
Consistency, context saving, and scalability. That is a powerful foundation for productivity.
Now that we really get the why skills matter so much for consistency and efficiency, we need to look at the engine. To really leverage this, we have to go beneath the user interface and understand the agent's architecture. This is where you see the sophisticated coordination that lets the AI act like a true professional.
Okay.
This is where it gets, for me, really interesting. The actual mechanics of how the AI chooses, activates, and executes a skill versus calling an external tool.
So let's peel back that curtain. When we're configuring a Claude agent, what are the three foundational components that dictate its behavior?
There are three core components in the agent configuration, and they operate in a pretty strict hierarchy of purpose.
Three components. Okay, give us the rundown.
First up, you have the core system prompts. These are the static rules. They're the agent's unchanging identity and its foundational constraints. They define the agent's ultimate purpose, something like, you are a helpful, secure, and professional developer. These are sent to every single conversation, no matter the content. They set the baseline tone and security posture.
So like the non-negotiable constitution of the AI.
Exactly. Second, you have the equipped skills. These are the internal specialized capabilities we've been talking about. The codified logic, the procedural knowledge for handling specific data types or customized methodologies. Think how to structure a design using Tailwind, or how to securely handle financial data. These skills live internally inside the agent's execution environment.
Okay, so skills define the internal process and methodology. What's the third piece?
The third component is the equipped ACP servers. Now, MCP is just the framework that allows the AI agent to call external tools. And this distinction is absolutely vital for any advanced usage. Skills define how to do something, providing the methodology. MCP servers provide the external capability to interact with the real world. They provide the action.
Let's nail that down. What do those external capabilities actually look like in practice?
MCP servers are all about real-time interaction. They are the standardized interface for external tools like performing a live search on the internet, calling a proprietary API to fetch data from a corporate database, committing code or creating a pull request in GitHub, or even kicking off a deployment pipeline.
So the agent uses its skills to understand my request. And if that request requires reaching outside its own little world, it calls the right MCP server tool.
Precisely. And it does so using what you called a strictly defined contract.
Wait, strictly defined contract. Does that mean the MCP server needs specific formatting, almost like API documentation, for the agent to know how to use it reliably?
That's exactly it. This is the crucial technical anchor. The MCP framework demands that these external tools are defined by clear JSON schemas, which are often derived from OpenAPI specifications. This ensures that when the skill decides to call that external tool, it knows exactly what parameters to send, what data format to expect in return, and how to handle any errors. This standardization is what makes the tool usage so predictable and reliable.
It's coordinating internal specialized knowledge, the skill logic, with external documented action capabilities,
Right.
the MCP tool contract. But how does the physical execution actually happen? Where does the code for these skills run?
That all happens inside the agent virtual machine, or VM. Every sophisticated Claude agent operates within its own dedicated sandboxed environment, the agent VM. This is the engine room. And it's essential because it gives the agent access to fundamental computational tools and programming environments.
Can you elaborate on why that sandbox environment is such a game changer?
2 words: security and guaranteed execution. The VM ensures that any code the agent generates or executes, whether that's a quick bash script to manage files or a complex Python script to format data, it all runs in an isolated environment.
Which prevents external tampering.
And it guarantees that the necessary computational resources and base operating systems are available. This is what allows Claude to confidently process data and manage files without, breaking anything.
And what specific languages or tools are available inside this sandboxed VM?
The standard setup gives you Bash for fundamental shell commands and file system management, Python for complex scripting, data manipulation, and structured logic, and Node.js for anything web-based or JavaScript-heavy.
So the AI isn't just pretending to run code, it's actually generating and then executing it inside a controlled environment to verify assumptions or manipulate files.
Exactly. Now, within that VM, the file structure is also critical. It contains the essential skill directory. This is where all of your activated skills reside. When you upload a skill, it lives in this directory, accessible to the VM.
Let's focus on the physical structure of a skill then. If I were to open that skill directory, what's the one thing I absolutely have to find?
The mandatory component is the skill.md file. It's just a simple markdown file, but it is the critical identification document, or as we said earlier, the manifest for the skill.
Why is that simple markdown file the most important piece of the puzzle?
Because it contains the natural language description of the skill, what it does, its purpose, and the conditions under which it should be used. Claude's core model reads this description to determine relevance. If your description is vague, or if it doesn't clearly state the trigger conditions, like use this skill whenever the user discusses payments, Claude might fail to call the skill accurately.
And you're right back to the inconsistency we were trying to fix.
Exactly. The quality of that skill.md file directly determines the reliability of the trigger.
So it's literally the user manual for the AI itself, defining its scope and trigger.
Yeah.
What else can be in there?
Well, alongside that manifest, the skill directory can contain optional data sources. This might be proprietary reference documentation, complex config templates, or specific data sets the skill needs. And most importantly, it can contain optional Python scripts. These are custom scripts that execute after the skill is triggered, providing really specific, complex instructions or pre-processing steps that guide the AI down the correct path inside the agent VM.
So the Python script is doing the heavy lifting, the complex logic, while the skill.md handles the initial identification and triggering.
Precisely. Let's trace that workflow again, maybe with a more advanced data processing scenario. Let's say a user prompts. Please analyze the attached Q3 financial CSV, cross-reference it with our historical pricing data from our API, and then generate a variance report.
Okay, that's a complex task. It requires internal logic, file manipulation, and external data fetching.
So the core system prompts establish the professional tone. Then the AI reads financial CSV and variance report. It scans its skills and identifies the financial analysis skill by reading its skill.md. That skill triggers.
And now the skill knows the methodology, how to calculate variance, what metrics matter.
Correct, but the task needs two distinct actions. First, processing the CSV. The skill uses the agent VM's Python capabilities to read the CSV file from the internal file system, maybe cleaning it up and structuring the data.
Yeah.
Second, it needs that historical pricing data. The skill knows this requires an external action.
So it calls the appropriate MCP server tool.
Yes, the historical data API tool, using that standardized JSON contract to fetch the required info.
And once both the internal processing of the CSV and the external fetching from the API are complete, the skills methodology guides the final Python execution inside the VM to combine the data, calculate the variance, and format the final report for the user.
It's a complete automated chain reaction. It's coordinating all these complex components with a level of rigor and security you simply cannot get through basic conversational prompting. Understanding these mechanics is what lets you truly master skill creation.
We've established the why, the consistency, the efficiency, and the how with the VM and the skills versus tools.
Yeah.
Now let's move from that abstract architecture to concrete application. We're going to look at 4 really powerful skills, all anchored around the source materials example of building a bookkeeping application to show how these specialized agents deliver that 10x productivity gain.
These examples are fantastic because they show you how to move past simple text generation and start delegating senior-level decision-making and project execution to the AI.
Okay, let's start with the visual one. Skill 1, the front-end design skill. We touched on this for consistency, but how does this skill ensure its production-grade quality?
The whole purpose isn't just to make it look nice, it's to create professional interfaces with a defined, high-quality, and maintainable design system. The skill codifies not just colors, but best practices for layout, for responsiveness, for component usage.
Walk us through the process from the source material. How did it start?
Well, the developer simply activates the skill and gives it a high-level goal, something like redesign the public-facing site and the logged-in dashboard for a modern, approachable feel. The skill, which has been preloaded with a sophisticated design SOP, just takes over from there.
What were the specific visual results on that bookkeeping app example?
The transformation was comprehensive. The original design, it relied heavily on a standard kind of corporate blue palette. The skill shifted it to this vibrant, clean green theme. But crucially, the skill updated the entire design language.
So not just the colors.
Not just the colors. This included the primary and secondary colors, sure, but also the shadow depths, the border radii, the hover states of every interactive element.
So it was basically managing the design tokens for the entire project.
Exactly. And on top of that, the typography stack was updated for optimal readability and a modern aesthetic. The layout elements themselves, things like testimonial blocks and calls to action, were completely reconstructed to adhere to responsive design principles. That guarantees a seamless experience on mobile devices, which is, an area where general prompts often fail.
And the real proof of the skill's value is in the consistency, right?
Absolutely. The application of the skill was holistic. That standardized style, the green palette, the new typography, it was all maintained perfectly across both the public landing page and the protected, logged-in dashboard where the user is doing their work.
So the skill understood the distinction between the pages, but enforced that visual unity.
Yes. And that alone saves days of manual component styling and verification work across the whole code base.
Wow. Okay, now let's switch gears to a purely business-focused skill. Skill 2, the domain name brainstormer. This one tackles the universal headache of naming a project and checking availability.
Oh, for entrepreneurs and developers, this skill is priceless. Its core purpose is to find an available domain name that is the best functional fit for the project and its target audience, while also doing all the necessary real-time market checks. It leans heavily on those external tools, the MCP servers.
What's the input from the user, and what does the skill do behind the scenes?
The input is super simple, just the project description, like a modern bookkeeping app for freelancers and small tech businesses. The skill then coordinates the whole process. First, it uses its internal logic, its Python scripts, to analyze keywords and audience demographics. Then it calls an external MCP server tool that's connected to domain registrar APIs to check real-time availability.
And what kind of output does that level of sophistication give you? I imagine it's more than just a list of names.
Oh, it goes way beyond the simple list. The AI generates a ranked, curated list of suggestions, and they're categorized based on a top-level domain or TLD strategy. For instance, it identifies premium.ai domains that communicate technological sophistication.
Which is perfect for a tech app.
Right. Then it gives you essential strong.com options for ultimate credibility, and also modern forward-thinking extensions like .io or .tech, which really appeal to the developer community.
And does it include the reasoning behind the choices?
It does. For each suggestion, the report includes critical metadata. You get a short SEO score assessment, an explanation of its relevance to your target audience, and its potential memorability factor.
Right.
But the most valuable technical detail is that real-time availability check, complete with registration findings.
Registration findings. Does that mean it gives you cost estimates?
It does. It not only confirms if it's available right now, but it also gives you a realistic budget assessment. This includes the minimum 2-year registration cost for standard domains, and it'll highlight the likely cost range for acquiring any premium extensions it recommends.
So it provides the entrepreneur with an immediately actionable short list of names, already verified for availability, relevance, and budget. That bypasses that whole painful cycle of thinking of a great name, finding it's taken, and starting all over.
Exactly.
Okay, now we enter the high complexity zone. Skill 3, the Stripe integration skill. Payment processing is a definition of a high-stakes, security-critical task. How on earth does a skill manage the sheer depth of implementation needed for something like subscription services?
This is a perfect illustration of codifying security and business logic. The skill's purpose is to ensure a consistent, secure, and compliant implementation of all payment flows, all enforced by industry best practices. Specifically, the standard operating procedures for Stripe integration, which are loaded right into the skill's data sources.
Where does the implementation process even begin with the bookkeeping app example?
It starts with a comprehensive analysis phase. The AI, guided by the skill, analyzes the existing application codebase, and it immediately identifies the lack of payment features. The skill then applies its business intelligence logic, recognizes that a bookkeeping app needs a subscription model, and proactively recommends a standard yet flexible tiered pricing structure: Starter, Growth, and Pro.
So it's acting as the integrated product manager and lead architect all at once.
Precisely. But the skill understands that implementation needs external variables. This is what triggers the dynamic Q&A phase. Claude uses the skill's procedural guide to ask the user these clarifying, critical questions. Things like, what's the duration of the free trial you want to offer? 14 days, 7 days, or none? What are your Stripe API keys? What are the rules for plan upgrades and downgrades, specifically around prorated billing?
And the developer can just instantly modify these variables. So if it recommends a 14-day trial, they can just say, make it 7 days.
And the skill instantly rewrites the entire subsequent technical plan based on that one input. The detailed plan that comes out of this is the core of the 10x gain. The plan it generates is a complete technical specification, ready for immediate coding.
What does that plan cover?
It details the feature gating tiers, ensuring growth users see tax optimization features while starter users don't. And crucially, it blueprints the required digital infrastructure.
Let's get into that infrastructure detail. What database schema adjustments does the skill actually plan out?
Well, it designs the necessary database schema for subscriptions from scratch. This is vital. The plan specifies the exact fields you need in your users and subscriptions tables. Fields like Stripe Customer Ed, Subscription Ed, the current plan status active, past due, canceled, and the critical current period end timestamp, which tells your app when the subscription expires. Without those fields, your application can't manage access control.
And it also defines the application architecture itself.
Yes. It details the specific back-end API routes you'll need, like a create checkout session route, and the necessary front-end integration for displaying pricing and managing the checkout flow. But most importantly, it covers the security aspect by defining the webhooks.
Webhooks are often the most complex and error-prone part of payment integration. Why are they so critical?
Webhooks are the communication channel where Stripe tells your application about events that happen outside of the user's browser. For example, if a payment fails 2 days after checkout, or if a user cancels their subscription directly in the Stripe dashboard, your database needs to know about it.
Ah, right.
If you don't implement the webhook listener securely and correctly, your application and Stripe's records will get out of sync. That leads to users getting access they haven't paid for, or even worse, being locked out unfairly. The skill ensures the webhook receiver is properly implemented, verified with a signature, and handles all the necessary event types securely.
That is literally weeks of architecture and security review done in minutes. How is this verified in the source example?
The verification phase is key. The AI doesn't just hand over code, it gives you deployment instructions. The user is guided to populate their environment variables with the necessary keys and the generated Stripe pricing IDs. They navigate to the app, choose the growth plan, and start the 7-day free trial. Then they use a specific test card number from Stripe to process a transaction in the sandbox environment.
And the final confirmation.
The user sees the successful subscription confirmation inside the application, and the skill confirms that the database records reflect the correct subscription ID and the new growth tier status. It proves the entire end-to-end integration is not just securely coded, but functionally operational.
Incredible. Okay, now for the ultimate power move, Skill 4, the Skill Creator Skill. A skill that is designed purely to take expert knowledge and automate embedding it into the Claude architecture.
This is the meta skill. It's the ultimate productivity hack. Its purpose is to automate that really difficult process of, ontological engineering. It translates unstructured, high-level human expertise into the structured, machine-readable logic, the skill.md, and Python scripts that you need for guaranteed execution.
Let's look at the scenario from the source. Creating a rigorous code review skill. That's something that demands years of senior experience to do consistently. How did the user compile the knowledge for that?
The user actually leveraged Claude itself to perform this enormous comprehensive research synthesis. The source noted it involved analyzing over 432 external sources. And this wasn't just checking for semicolons. The research covered the philosophical core of modern development, established Nest.js architectural patterns, React TypeScript best practices, and critically, these sophisticated multi-perspective review methodologies.
Let's dig into those perspectives. This is what truly elevates the skill beyond just a static linter. Who are the 6 expert voices the AI embodies during the review?
So the AI, guided by the skills methodology, reviews the code through the lens of 6 different roles: the architect, the product manager, or PM, the QA engineer, the business analyst, BA, the user experience UX designer, and finally, the senior developer.
Give us some examples. What specific scrutiny does each perspective provide?
Certainly, the architect checks for scalable design patterns, service segregation, and identifies potential immediate blocking issues that could compromise long-term maintainability. The product manager ensures the code actually solves the intended user story, checking for feature completeness against the requirements. The UX designer scrutinizes the front end for adherence to design systems, accessibility guidelines, and verifies mobile responsiveness.
That is extremely detailed. What about the QA and business analyst roles?
The QA engineer perspective is focused heavily on robust error handling, boundary testing, edge cases, and logging. The business analyst checks for alignment with business goals, ensuring database interactions comply with data retention policies or regulatory requirements. And then the senior developer handles the line-by-line inspection, hunting for technical debt, performance bottlenecks, and adherence to specific language best practices.
So years of institutional knowledge, all codified into one reference file. How did the skill creator turn this unstructured knowledge into the functional Nest.js code review skill?
The user simply pointed the skill creator still to that compiled research file and prompted it to generate the methodology. The skill creator read the text and automatically structured all that content into the internal logic the AI needs, generating the skill.md manifest and the necessary guiding scripts.
And what was the resulting standardized methodology it created?
It produced a rigorous, standardized 4-phase methodology that the AI will now follow without fail for every single code review request. This is what enforces that consistency across all projects.
What's phase one?
Phase 1 is the architecture and high-level design review. The AI steps back to assess the overall structural integrity of the code submission. It's looking for those large-scale anti-patterns or blocking issues that have to be resolved before you can even move on.
And phase two?
Phase 2 is the file structure and naming convention review. This focuses on project organization, making sure it adheres to the established directory structure, modularity, and internal naming conventions. It's critical for future developers who have to onboard to the project.
Then the deep scrutiny happens in phase three.
Exactly. Phase 3 is the detailed component review. This is the critical phase where that line-by-line inspection occurs, filtered through the combined expertise of those 6 perspectives we just discussed. The AI meticulously checks every function, class, and component against the codified standards.
And phase four closes the loop.
Phase 4 is the documentation and test coverage review. The AI verifies that the code is adequately commented, that functional documentation is up to date, and that the necessary unit and integration tests are present. And then the skill concludes by generating a comprehensive, standardized review report. This report details all the findings, categorized by phase, severity, and the specific perspective that raised the issue. It gives a clear approval status or reasons for rejection.
This is the pinnacle. You've used AI to synthesize deep, high-level expertise, and then used a skill to embed that synthesized expertise into a reusable, consistent agent. It guarantees every developer gets the same rigorous, senior-level feedback every single time. It truly delegates one of the most time-consuming tasks in engineering management.
It transforms the AI from a simple coder into a consistent, multi-perspectival senior reviewer that operates with the rigor of a highly paid consultant.
What an incredible tour through the architecture and practical application of Claude skills. We really saw how this shift moves the conversation away from just general prompting and into high-fidelity, repeatable workflow automation.
And to reiterate the core value, Claude's skills offer reliability, efficiency, and scalability. By codifying deep, complex knowledge, whether that's security requirements for Stripe, a custom front-end design standard, or a 6-perspective code review methodology, and embedding it directly into the tool, you ensure that every interaction is drawing upon the best, most relevant, and most consistent set of instructions tailored just for you.
It eliminates that constant need to remind the AI who it is and how it should behave. You are starting every project, every analysis, every piece of code generation from a foundation of codified senior-level expertise.
And this whole approach, it addresses information overload by making sure your AI helper is optimized for your specific domain and your standards. It saves context, it saves time, and ultimately it saves money.
Exactly. So if the skill creator allows you to instantly capture and embed this kind of institutional expertise into an AI, we'll leave you with this final provocative thought.
What is the single most complex, time-consuming process in your day-to-day work? A process that currently requires you, the expert, to perform with the highest level of consistent, multifaceted execution that you could transform into a reusable skill. Think about standardizing your genius and then letting the AI execute it at scale.
Thank you for joining us for this deep dive. We'll see you next time.